Hello, my name is Klaus Dimitri. It's my article presentation on the New York Times article project. My article's title was Flies That Do Calculus with Their Wings. The author was James Gorman, and the date of publication was March 19th, 2014. I thought this article was incredibly interesting because it talked about the strange nature of our world. How our normal everyday housefly, which you wouldn't expect much of anything from, has essentially a microscopic brain with the neurons with the capability of processing calculus-level problems mid-flight in a matter of milliseconds, something which to us is incredible, because for us to reciprocate such a feat requires computers with advanced programming, gyroscopes, and various sensors, while a typical housefly, which is no bigger than a centimeter, has the innate ability to do all that in less than a blink of an eye. The author is conveying the curiosity of the scientists to research such an incredible feat from such an ordinary organism. He is trying to convey the scientists' interests in discovering what type of mathematical formula that the neurons of this organism uses so precisely to recover from a mid-flight disturbance so quickly. Um, I learned some interesting thing. What I thought I learned from this article is that it helped me recognize that animals that fly, especially insects, have a lot of mental processing to do while they fly. Suppose that a modern-day aircraft had to maneuver the way a housefly does. Now imagine that same aircraft doing maneuvers in a storm, which would be scaled up from the gusts of air blowing on the housefly, or the magnets that they used in the experiment to disturb the housefly while it moved around. Now, now if you think about all that, you can truly see how these animals are incredible, and that we still have a lot to learn from the organisms around us. That's essentially what the article taught me, that we don't think much of these tiny organisms around us all, but while in fact they have a lot that they can teach us. And if I was supposed to, yeah, I suppose I were supposed to research more on this topic. Where I might look is that I might search up the mathematical processes that a modern day aircraft undergoes to stabilize itself when flying, and the hardware and software required to do so. Then I'll compare that with a more extensive research on the subject of insects and processes they undergo to stabilize itself. And what I would expect to find with all this research is that we have a lot to learn from these little buggers. And how I think this article relates to our what we're studying in psychology is that it touches on the subject of both voluntary and involuntary mental processes within neurons. And it is interesting because we're studying complex nature of our brains and how we have various parts of our brains that control and process various other parts of our brain, as well as having abstract thoughts and ideas. And then we see this housefly, which is no bigger than one of our fingernails, and we would think it'd have a relatively simple brain structure. But then we stumble upon this research, such as this housefly has neurons that process on a calculus level. And we see how there's a lot left to know about the nature of organisms around us, and even ourselves, and even our own brains. And that's essentially what this article uh, brought to me for me to think about. But that was the end of my presentation, and I actually enjoy these presentations a lot. They make me think in a different way. I'll read an article and then I'll read it, but I won't think much about it. But doing this project makes me see it on a whole new level. It's very interesting. But that was my New York Times article. Thank you very much for watching.